Hi, good afternoon, everyone. My name is Dr. Sahar Majri. I've been working with both Dr. Wills and Dr. Ritchie on a USDA-funded project looking into improving the different parts of the life cycle of warm water marine species. Today, I'm going to share with you results about replacement of live feed by a commercially formulated diet in Marine Florida Pompano larvae. This is a study that we've done in collaboration with two hatcheries. They are our partners. So it was conducted in the setting, the hatchery setting, producer setting. So as we know, production of marine fish juveniles still depends widely on live prey, mainly rotifers and Artemmia. Efforts have been made since the 80s to replace live feed, but unfortunately, this didn't reduce entirely the reliance on Artemmia and rotifers. They couldn't, microdiets developed to date, they couldn't achieve completely, a total replacement, basically, of live feed. So it is hypothesized and also known that the digestive tracts of larvae are not well developed enough to take microdiets. However, and some hypotheses also is that it's linked to digestive enzymes. So there is this a study that back in the 90s showing that, putting into hypothesis that the digestive enzymes in larvae are not sufficient enough to take microdiets. But recent studies have shown actually that the enzymatic activity of larvae is very high as related, of course, relative to their weight. So we want to get rid of live feed because rearing fish larvae is already complex as it is, and maintaining the required rotifer quantities and keeping consistent quality is still a challenge. And we hear it from our partners how their sometimes starter culture doesn't work, how their rotifer production collapses, and so on. So it's not very predictable when you are trying to commercially produce fish species. Being able to completely replace rotifers and Artemmia would improve the fry quality, the performance, definitely simplify the weaning process, and produce more healthy and predictable high quality of juveniles. And of course, reduce the cost of production and allow hatcheries to simplify their process of producing juveniles. All right, so the objective, as I said, here is to replace rotifers and Artemmia for Florida Pompano larvae. So here I'm going to go through the experimental design we used. Oops, is there a pointer? No. So here, the first one is the control, and then I put there just a guide. Each farm does what normally it does because it's proprietary information. But overall, you have a period where you introduce rotifers. Then after 8 days, more or less, you add Artemmia, enriched Artemmia, so on, until between 20 and 24 days post-hatch, you feed the microdiet Otohimi. So one first treatment we did was to replace 50% of the rotifers and Artemmia by the MV diet, which is the microdiet we trialed. I'll tell you in the next slide about that. And we did another treatment with 80% replacement of both. So we replaced 80% of the rotifers and 80% of the Artemmia. And final treatment was 80% replacement only for Artemmia. And this was intended first to do 100% replacement, but given that we were working on commercial hatcheries, we didn't want to risk their production. But this is something we are gonna do at our aquaculture research facility. So we replicated 4 times for each treatment. There on the right, you have the stocking densities at each farm. The microdiet we used is called MV pellet that is imported from Europe. So you have different sizes here because you have to respect the mouth gap of the larvae when we are introducing these. So you have inferior to 100 micron, between 100 and 250, and then you have a bigger sizes. But overall, the nutritional composition is the same. Right, so I told you basically our sampling was strategic. We sampled at stocking to have the profiles of the eggs, nutritional profiles, 8 days, so that represents, and this varies from farm to farm, represent the last day before we added Artemmia, and then we sampled at the last day before we started the Artemmia diet, the microdiet toward the end. And then our last sampling was after a few days after feeding pure microdiet or Artemmia. So here I'm going to show you length and weight, and then show you some fatty acid profiles, lipid profiles in relation to those treatments. So here in the length, on the y-axis you have the length in millimeter, and on the x-axis you have the days post-hatch, as explained earlier. So at the very beginning, you can see that there is not that big a difference in terms of length. Then around 18, you see that the control does a little better, and comparable to the 50% replacement treatment. Then there you see 2 dates here, 29 and 31, because this was at one farm and this was at another farm. Here you can see a huge variation because one of our partner hatcheries experienced like a cold front during the transfer from rotifers to Artemmia, so they don't really translate very, I would say, directly the impact of the diet. So mostly look at this result. So you can see, yes, the control are bigger with a little bit less variation, and all the replacement treatments were similar, but slightly smaller. In terms of weight, the differences were obvious more here at 18 days post-hatch, with a little bit bigger fish for the control, but we didn't have any statistically differences toward the end, and you can see the variation was quite important. So this study, we're going to repeat this study with 100% replacement to mostly see what we are getting. Do you still have time? I feel like I'm speaking so fast. 3 minutes old.
6 minutes.
Okay. So this NMDS here show the overall profiles for fatty acids for most of the treatments. Okay, I'm going to zoom in on each day in the following slides. But what I want you to notice here is like how toward the end of the experiment, when the fish were fed few days on Artemmia, how all treatments were similar, basically. All right, so I'm going to go day by day to explain myself. So here at 8 days post-hatch, you can see that the 80% replacement of Artemmia and the control clustered together, which makes sense because at that point we didn't replace the rotifers, so they were fed exactly the same thing as the control. However, the 80% rotifers and Artemmia and 50% rotifers and Artemmia here were clustered together, showing higher profiles or proportions of certain essential fatty acids, mainly the DHA, which is an interesting result. Moving to 18 days post-hatch, we can see here that all the treatments were clustered together regardless, with the control far away. And the profiles here of the lipids show that they have incorporated essential fatty acids like EPA and DHA. So they are definitely ingesting the micro diet and incorporating it in their tissues. So here, the last slide of the results, I'm showing how, regardless of the treatments at the beginning of their life stages, when they were fed, all of them on Otohime microdiet, we don't see any differences in their overall profile. So it didn't affect their ability to incorporate fatty acids in the same way from Otohime diet. So in conclusion, I want to say that nutritional profiles, mainly the lipids here I showed you of larvae, were similar towards the end of the experiment, regardless of what they were fed at the beginning of their life, transitioning to Otohime. So this highlights the impacts and the effects of the INVI, basically how INVI diet, this commercial micro diet, developed specifically to replace live feed, did not have actually a nefast effect on larvae growth and incorporation of essential fatty acids. So this diet was actually trialed with sea bream in Europe, and they had great results with a total replacement. So we kind of took a chance with Pompano, and we are really very happy with what we found. We're going to do this study again starting in March with 100% replacement, and we're going to see what we get. We're going to also have a tighter control on the temperature, because with our partners in the hatcheries, life happens with fish and temperature drops, and that can mess up your whole design, which is nobody's fault. I want to also emphasize that some work needs to be done to refine those results, mainly regarding species-specific digestive enzymes and capabilities. I think that will help in the development of microdiets in the future. I want to emphasize always in my presentations how fundamental research really help advance aquaculture, and we should not overlook that. Thank you for listening to me, and I want to acknowledge everybody who funded this work, and my colleagues and all the students, of course, who help all the time. Thank you.
We have time for one question. This guy.
My hand up first. So this is really interesting. Thank you for the groundbreaking work you're doing here. I think it's really important.
Thank you.
Did you ever notice any issues with the learning curve of the baby fish to try and figure out how to eat a pelleted diet? I mean, typically the movement of a live feed will create that instinctual hunting response. Did you notice anything?
That's a very good question, and my response is limited because, unfortunately, I'm not the one observing all this, because this happened at our, I don't know if Nicole Kirchhoff is in the room. No, I don't see her either. But we heard from, the reports that we got, that they accepted it very well, and they were, on it. One of our partners said that she tried it with another fish species, and it worked really well. She did it with another one, and it worked less well. So that's also, so she told us that they are taking it. There is palatability, they are attracted to it, basically, even though it's not moving. I guess your question is like, it floats.
Slow
Right?
sinking. At first it'll float, and then it'll start dropping through not a real fast rate, though. When you get to the larger pellet sizes, it goes much quicker than the smaller pellet sizes.
Thank you.
Very well.
I think on the very smallest size, we had to actually, because it wouldn't break the surface.
Surface tension.
So we had to first add it to water and then put that in.
Yeah. Yeah. Cool. Thank you, guys.
All right.